Okay, so we'll start really easy, we'll slowly get more complicated. Okay, first example, draw this for me. Let's say this is 8 inches, this over here is 3 inches. How do I find the area? Spencer? Okay, 3 times 8. I want you to write out, and you can fight me on this all you want, this is non-negotiable, okay, because when we get to harder ones, it's going to be important that you're in this habit. I want you to write out area equals 3 times 8, and then area equals 24, because 3 times 8 is 24. You must write this out to be getting credit. I know you can do 3 times 8 in your head, or at least type it in a calculator, but I want to see what you're doing. Spencer?
On my test and quiz,
Yes. Yep. Yep. Mostly because that allows me to give you partial credit on things. What happens a lot with problems like this is I'll see people get everything set up correctly, and I'm talking about some of the more complicated formulas like trapezoids, circles, stuff like that. People will get everything set up correctly and then make some sort of mistake calculating it, some sort of mistake typing it into their calculator or something like that. Well, if I can see that you set it up correctly, you'll probably get most of the credit for that problem because you just made a mistake typing it in your calculator. Okay, so that's why that's important. Now let's talk about how to label this. Okay, what does that 24 mean? Think back to what we did on the board. Darian? Okay, 24 inches would be like 24 little segments like this. Is that what I was counting? What am I counting, Spencer?
24 units.
Okay, so, and these are inches, so I can say square inches. What that means is if I were to divide this up into squares, there would be 24 squares inside that figure. And so what I'm really measuring is the space on the inside.
Is units only when you don't have, like,
Exactly. Yep. If I give you a unit, units are things like inches, feet, yards. If I give you something like that, that's what you should be using in your answer. If I had just given you 3 and 8 with no units on there, then you can just say units because you don't know what the unit is. We'll do an example like that in just a minute. Okay? Good with that? Let's try a square. And we'll make this 4 centimeters. Now what's the problem here? Rebecca? Okay, so that's actually the solution to the problem. The problem is I only gave you one number, right? Right? Do you see how this is different than that because I only gave you one measurement? But Rebecca, why does that not bother me? Right, so everything is 4, which means if this is 4 centimeters, then this is 4 centimeters. Okay? So to get my area, what 2 things am I multiplying together?
4.
Yep, 4 and 4. So 4 times 4. So it would be, what is that? Nope, 4 times 4. 16. And how do I label that? Okay, yep, square centimeters, which is centimeters with a little 2 above it. Okay? Does that make sense? Okay. Try a harder one. And I'm going to give you that this is 10, that this is 5, this is 12, and we'll say this is 4. Okay, go ahead and draw that figure. List those measurements. Do you know of a formula for a shape like that? Do you have a formula for an L? Not quite. Good thinking. Okay? But that's the type of mistake I see that messes people up. It's not just multiplying them all. I don't have a formula for a shape like this. I don't know of any formula for a shape like this. But what I can do, oh, Jacob?
Can't you like split them up?
Exactly. I can split it into shapes that I do know how to work with. Okay? So I don't care how you cut it. I'm going to just draw a line here. Okay? And now I have a rectangle and a rectangle, right? And I know how to work with rectangles. Now here's the tricky part about this. Is I know this whole side is 12, but for this rectangle, I just want to know this length. Anyone have any ideas how to get just that length? Jacob,
6.
how'd you get 6?
Split 12 in half.
Okay, good thinking, but you can't make that assumption. You can't assume that it's only half. Okay, that is, again, another mistake I see a lot. Alexis, what do you think?
12 minus 5.
Okay, where'd you get 5 from?
The other side, so that would give you the rest of the side.
Good. I know this over here is 5, which means since this is a rectangle, I know the opposite side is going to be the same. So this little piece here is 5. So if I know this much is 5 and I know the whole thing is 12, I can do 12 minus 5 and I get 7. So see, it's awfully close to 6, but I can't assume from the picture that it's split, especially if it's a picture I've drawn. Okay, Jacob, go ahead.
Does it matter how you split the shape?
It doesn't. Nope. So like you're thinking maybe you could have split here instead. That would work too.
Okay.
Yep. As long as you're splitting it and finding the numbers correctly, any split would work.
Oh,
Okay. So if I wanted to do the area of this rectangle on the top, what two things would I multiply together? Javante, what do you think? What two things would I multiply? Not quite. 12 would give me this whole side. I just want this rectangle. Okay, yep. So 4 and 7. So the area of that top one is 28. Okay, we'll come back and talk about units in a minute. So that's this one. Now I want to do this bottom one. What am I going to multiply for the bottom one? Yep, 5 and 10. 10 and 5. Does it matter which way you do that? 5, 10, 10, 5? Doesn't matter a bit, does it? So the area down here is 50. Okay. So if I want the total area, what am I going to do with these two answers? Add them together. Yep. So 28 and 50 makes 78. Now here I didn't give you a length, right? I didn't give you like a centimeters or yards or anything like that. So this is where I would just say units in general. Anytime I don't give you a number, you can just call it units. And I'm okay with you abbreviating units with just a U. Okay, so you could say U squared. Good with that? So just to kind of come back to what Jacob asked a second ago, I could have also split this here and then treated this like its own rectangle and this like its own rectangle. I would have ended up with two different numbers, but when I added them together, it should still come out to 78. Did anyone try it that way? No? Okay. I don't want to make you think that you have to do it both ways, so we won't go into that now. But yes, you could have split it a different way. Split it in whatever way looks the easiest to you. Let's do one more. It's kind of weird. Let's do a picture frame problem. Let's see. I've got a rectangle on the outside and a rectangle on the inside. I'm going to say this is 3 meters. This up on top is 6 meters. This is 8 meters out here. Oh, this is 10 meters here. And this around the outside is shaded. Okay. This looks a lot prettier on your actual worksheet, but okay. And what I want to know is what's the area of the shaded space? Okay. Anytime you're dealing with shaded area, usually what it is it's like a shape inside of a shape. So I want you to picture this as though I had this rectangle, the 10 by 8 rectangle, and I cut a hole in it right here. If I'm cutting a hole in it and taking it away, what math process does that sound like, Spencer? Subtraction, yeah. So I want to take the area of the whole thing and subtract the area on the inside. So I want you to always think, when I'm asking you a problem about shaded area, that's almost always a subtraction problem.
The 3 and the 6, which one is the big one?
Well, the 3 would be up the side, and the 6 is along the top, which means it could also be along the bottom.
Okay, so 6 is the base.
Yep. Okay, so shaded area always means subtraction. So I'm going to do the area of the outside. And by the outside, I mean the big rectangle. That would be this. How do I find the area of that big rectangle? 10 times 8. Which means my area there is 80 square meters. Then I'm going to do the area of the inside rectangle. What would I multiply for the inside rectangle? Okay, 3 and 6. Or 6 and 3, it doesn't matter. Everyone see what I mean when I say inside and outside? So area is 18 square meters. And then, like back here, I added these together because I wanted that total area. This time, I want to take this area away from that. This 80 means that this entire thing would have an area of 80. But I want to cut this piece out of the middle of it. That's why I'm subtracting. So I would take these and subtract 80 minus 18 and get 62. Did I subtract that right? 70, 62. 62 square meters is my final answer. Okay? Those are the types of things you're going to encounter right now. What I'm going to have you do is the front of this worksheet, I would like you to do that right now here in class. Probably give you about 20 minutes, and then I would like to grade it. Depending on how well you did, we might try to add something else onto this today, or we might just focus on the rectangles and squares today. Okay?